In this video, we're going to be looking at factoring algebraic expressions. So the question of the day is, how do you factor an algebraic expression? So how do you factor an algebraic expression? Well, first of all, what is factoring? When you factor an expression, you are breaking it into its factors. So remember, when you multiply two numbers, each number that you're multiplying together is called a factor. So just to give you an simple example of factoring, factoring numbers is breaking numbers into two numbers that multiply to get you that number. So I can factor 10 into 5 times 2. So I'm breaking 10 into its factors, two numbers that multiply to give me 10. I could factor 24 into 6 times 4. I could also factor it into 12 times 2 or 8 times 3. There's lots of different ways you can factor 24. And then I could factor the number 52 into 13 times 4. So that's what I mean by factoring. When you take something and break it into two things that multiply to get that number. So when you factor an algebraic expression, you are breaking it into its factors. So we're not going to be factoring numbers because that's a little too simple for 7th grade. We are going to be factoring algebraic expressions. So let's take a look at that a little more broadly first. We have used the distributive property to expand expressions. So that means we took A and we multiplied it by B and C to get A times B plus A times C. This is called expanding the expression, and that's what we've used the distributive property before to do, is to get rid of the parentheses. So we take everything inside the parentheses times what's outside the parentheses, and the parentheses are gone. But now we're going to use the distributive property to factor expressions. So now we're going to be going the opposite direction. So before we were multiplying using the distributive property, now we're going to be undoing that multiplication. So basically division. We're going to be breaking the algebraic expression into its factors. So when we do that, we're going to be starting with this and ending with this. So now we're doing it backwards. So we're starting with what we got after the distributive property, and now we're kind of undoing it and reintroducing those parentheses. Both of the terms have A here as a factor. So we can factor an A out, and A is being multiplied by B plus C. So really the essential thing you want to realize here is that factoring is the opposite of expanding. So now we're going to be undoing the distributive property. So how do you do that? To factor an algebraic expression, the first thing we need to do is find the greatest common factor, or the GCF, of the terms that we are factoring. And this is what's going to go outside the parentheses, because everything that we factor is going to have some number outside the parentheses and then something inside the parentheses, because we're undoing the distributive property. So the greatest common factor is going to go outside the parentheses. And then we just divide each term by the greatest common factor, and that tells us what goes inside the parentheses. So let's take a look at a couple examples here, and that might clear that up a little bit. So factoring these expressions, 10x plus 15. So our goal today is to take this and rewrite it to look like what it looked like before we used the distributive property. So what did this look like before we got rid of the parentheses, basically, is what we're trying to do. So the first thing we need to do is find the greatest common factor of the terms. The greatest common factor of 10x and 15 is 5. That's the greatest common factor of 10 and 15. So 5 is going to go outside the parentheses. We knew that both of these terms were multiplied by 5 to get them. So what goes inside the parentheses then? This was 5 times something plus something. Well, to get what's inside the parentheses, we're going to divide each of these terms by 5. So 10x divided by 5 is 2x, and 15 divided by 5 is 3, and that's what goes inside the parentheses. So this is the new expression after we have factored it, or basically undo the distributive properties. We get 5 times 2x plus 3. Now, a great way to check to see if you factored something correctly is to just do the distributive property again to see if you get what you started with. If we do the distributive property here and multiply everything times 5, 5 times 2x is 10x, and 5 times 3 is 15. We get 10x plus 15. We get exactly what we started with, so we know these are equivalent, and we know we factored it correctly. Another example, 14n minus 12. The greatest common factor of 14n and 12 is 2. 2 is the largest number that divides both of these, so I know 2 is going to go outside the parentheses. So 2 times what gives me 14n minus 12? Well, 14 divided by 2 is 7n. and 12 divided by 2 is 6. So that's what goes in the parentheses, 7n minus 6. And it was subtraction because I started with subtraction here. And again, to test to see if I factored this correctly, do the distributive property to check. 2 times 7n is 14n minus 2 times 6, which is 12, 14n minus 12. I get the same thing I started with, so I know that that is the correct factored form of that expression. So let's take a look at some more here and see if we can factor these. 4x plus 28. Well, what's the greatest common factor of 4x and 28? Well, they're both divisible by 2, and they're both divisible by 4, but 4 is greater. So we're going to use 4, and that's going to go outside the parentheses. So what's going to go inside the parentheses? Well, 4 times what gives me 4x? Well, 4x divided by 4 is just x, or 1x, plus 28 divided by 4 is 7. And there's my factored expression, 4x plus 7. Now, did I get this right? I'm going to check with the distributive property. 4 times x is 4x. 4 times 7 is 28. That checks out. I know I factored it correctly. So 4 times x plus 7 is the correct factored form of that expression. The next one, 3 minus 33t. The greatest common factor of 3 and 33t is 3. So 3 times what gives me the 3? 3 times 1 is 3, minus 3 times what gives me 33t. 33t divided by 3 is 11t. Don't forget your variables there when you divide. So I have 3 times 1 minus 11t. And again, I'm going to check this with the distributive property and expand it again. 3 times 1 is 3, minus 3 times 11t is 33t. That checks out. So I know I got the right factored form. 4x plus 35. The greatest common factor of 4x and 35 is 1. These numbers don't have a greatest common factor besides 1. So when they don't have a common factor, we're going to write cannot be factored. And that's possible. Not every algebraic expression can be factored. We call these numbers relatively prime because they don't have a common factor besides 1. So we just write cannot be factored and move on. Down here we have 5 minus 5c. The greatest common factor of these two terms is 5. These are both divisible by 5. And 5 divided by 5 is 1. And 5c divided by 5 is 1c, or just c. And that's my factored form. Again, I'm going to double check that with the distributive property. It never hurts, especially if you're fast with the distributive property. 5 times 1 is 5, minus 5 times c is 5c, and that checks out. I get back what I started with, so I know that that is correct. Next one, 32 plus 24x. The greatest common factor here is 8. And 32 divided by 8 is 4. Plus 24x divided by 8 is 3x. And again, if I double check that, 8 times 4 is 32, plus 8 times 3x is 24x. And again, that checks out. I get back what I started with, so I know I factored it correctly. Now, what happens if you don't choose the greatest common factor? What if you choose a common factor, but it's not the greatest common factor? So let's say I chose 4 here instead of 8 to put outside the parentheses. Well, I would get 32 divided by 4 is 8, and 24 divided by 4 is 6, so I would get 6x. And this would be a factored form of that expression. This would technically be correct, but it's not using the greatest common factor. Well, how do I know if I got the greatest common factor? Here's a tip for you. Look at what you have in the parentheses after you factor it. Do these two numbers still have a common factor besides 1? And the answer is yes. These still have a common factor, so I know that this is not the greatest common factor. If the terms inside the parentheses still have a common factor besides 1, you know you didn't find the greatest common factor. So that's a nice little tip to check for as well. These both have a common factor of 2, so I know I didn't get the greatest common factor there. So then I would just take that 2 times 4 to get my 8, which gives me my greatest common factor there. So that's just a side note on making sure you get the greatest common factor. And then the last one, 3z minus 9. The greatest common factor of these two terms is 3. And 3z divided by 3 is just 1z, or z, minus 9 divided by 3 is 3. And that's my factored form. And again, I'm going to double check that with the distributive property. 3 times z is 3z, minus 3 times 3, which is 9, and that's exactly what I started with, so I know I factored that correctly. So factoring is the opposite of expanding. It's kind of undoing what we've done with the distributive property before, reintroducing parentheses, and that's a skill we're going to need when it comes to algebra down the road in the future. And as always, double check your factoring with the distributive property. Make sure you do it correctly.